All right, y'all ready?
Let's get it. That means yes.
Oh, I guess we're recording. My light wasn't working. All right, here we go. Here's the table for sequence M. Define M recursively using function notation. So it starts with n equals what?
N equals what? 1.
1. And we start with M of 1 is 7. And we're doing what each time?
You're timesing. Oh.
So if we want a recursive definition for M of n, that equals,
M of n equals 7. Wait, are we doing
No, it's a.
Minus
no, it's
2.
m.
M,
M parentheses n minus 1, and then minus. What are we minusing by?
what is it minus and by?
2. Minus 2.
That's it. Y'all, that's it. There's no pain involved in this.
Just getting a little confused.
I like recursive. I'm getting that.
All right. Here, y'all know, y'all got the attendance party coming up. Some of y'all are still qualified, right?
See.
September 29th, attendance party, party in the courtyard, right?
Woo-woo.
Soft drinking games, right?
I'll be there.
All right.
I sure will.
Look, maybe they'll place hexagonal tables out there.
No, they probably won't.
They might, right? So,
What if they make us do algebra test?
I will die. I'll be late.
there's space for one person on each open side. Here's how they're going to place the tables in the courtyard, right? Complete this table showing the number of people P of n who can sit at n tables. So we've got, if you only had one table, you could set one person here, 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 and here. 1, 2, 3, 4, 5, 6, right? If you had two tables,
B12.
wait a minute,
No.
because you got to take one side away from one and take one side away from two. So let's count again. Y'all count with me.
4,
So how many we got? And for the third one, let's count.
gonna be
14, right?
14.
All right. What do y'all think before we do the fourth one? So let's check it out on the fourth one because we're going to pretend like these two are connected right here. And you can't sit somewhere where my finger is, okay? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think y'all are right. So what would the next term be?
22.
Painless, y'all, painless. This is painless stuff. Describe how the number of people who can sit at the tables changes with each step. How would you do this in words? Describe in words what's happening. The number of people who can sit at the tables,
Increases by.
Oh, yes, I need some tea. I don't know.
hey, don't get distracted. Number of people who can sit at the table does what?
Increases.
By 4.
And we'll say wait with each step. Doesn't that make, isn't that much fun? And part C says, why does P of 3.2 not make sense? Because you're not going to put 3.2 tables on there, right? We're only dealing in whole tables, right? And that, your favorite, Cammie,
Recursive.
define P recursively.
Wait, how do you do recursively for explicit verb?
Recursive and explicit are two different things, right?
I know, but you said the nth term equals explicit.
The nth term, what they're calling the nth term stuff is the same as we called explicit.
Okay, well, recursive and nth term are both in that.
Yes, we're doing two different definitions.
Oh, okay.
So the recursive definition we're working
I'm
on now.
sorry.
So what are we adding each time?
Or,
All right, and we also need to take, what do we start with? P of 1 equals what?
6.
Yeah, when you do a recursive definition, you really need to start starting term also.
you
Okay.
just giving it out.
Sorry. That's the recursive part.
Wait, do you have to add that P of 1 equals 6?
Where would you start if you didn't? How do you know you start with 6?
Oh. Well, I thought, oh, because it's asking for the 9 term, the end term, right?
Yeah. Yeah. So you'd have to know where to start. All right, so now for the nth term. It's an arithmetic sequence, you already told me. So how are we going to do P of n? We're starting with n equals 1. So what's this going to look like?
For recursive,
Yep,
it'll be, 6.
that's your first term.
Oh, you're still on that?
No, we're doing the nth term now. This was the recursive.
Oh.
Plus 4. Would it be to the n minus 1?
Times n minus 1, right? And this one, you don't have to declare what 6 is, or what P of 1 is, because if you plugged in n equals 1, you're going to get the 6. It's going to give it to you. Good? This is so much fun. We're at 7-minute video again.
Let's restart.
All right, time to restart.